Can exponents be negative? Yes, let's look at why. So the essential question is, how do I make sense of negative exponents? We're also going to look at zero exponents. So let's, I searched for, what did I search for? Negative exponent meme, and came up with this is actually a pretty good way to understand negative exponents, and we'll figure out why in a second. It kind of means flip the smiley face. But I just enjoyed what it was titled under, what the URL was. It was something like www.mathfunny.com/mathfunnyhumorjoke negative exponent smiley. And maybe you don't think this is funny at all, in which case, I'm sorry for wasting your time, but this is just like trying a little bit too hard. Anyway, let's follow a pattern to see what negative exponents and zero exponents are. So just bear with me for a second. Let's calculate 2 to the 4th, 2 cubed, 2 squared, 2 to the 1st. See what I'm doing here? I'm taking different powers of 2 and I'm kind of stepping down the exponent each time. So 2 to the 4th. Okay, this is 2 times itself 4 times. So that would be 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Wonderful. 2 cubed. It's just 3 of those 2's, 8. 2 squared is 4. 2 to the 1st is just itself. There's only one 2 there, so 2. Now let's take a look at a pattern here. As I decrease the exponent 1 each time, see what I'm doing? I'm stepping down the exponent 1 each time. And as I do that, what's happening with these numbers? What's the pattern? Really good mathematicians are those that can recognize patterns, and I'm recognizing this pattern of dividing by 2. So let's continue the pattern. I'm going to step down the exponent once more. 2 to the 0. Well, let's just continue following the pattern. What's 2 divided by 2? Well, that would be 1. So here's a 0 exponent. 2 to the 0 ends up equaling 1 if we follow this pattern of dividing by 2 each time. Similarly, let's continue following the pattern into negative exponents. So 2 to the negative 1. Shouldn't I just keep dividing by 2? What's 1 divided by 2? Let's just write it as 1/2. 2 to the negative 1. What's 1/2 divided by 2? Well, that's the same as multiplying by 1/2. So 2 to the negative 2 is actually going to be 1/4 if I continue the pattern. What do we notice? This is interesting. How are 2 to the 1 and 2 to the negative 1 related? They are reciprocals. How are 2 to the 2 and 2 to the negative 2 related? They are reciprocals. What do you think 2 to the negative 3rd would be? Do you think it would be 1/8? It is. What do you think 2 to the negative 4 is? Do you think it's 1/16? It is. Why? Because that's the pattern. Negative exponents really mean take a reciprocal. So, some definitions. A to the 0, meaning anything I want to the 0. It's always going to end up being 1. So interestingly, anything to the 0 power is 1. Many times people think it equals 0. No, it doesn't. It's 1. Follow the pattern. A to the negative 1 means reciprocate. So a to the negative 1 is 1/A. It means reciprocate. A to the n is a reciprocal of a to the negative n. So anytime we have a negative exponent, we should be thinking reciprocate. So negative exponent, it does not mean make the number negative, it means reciprocate. That's why when that math funny humor thing before was, if you have a smiley face to the negative 1, you are reciprocating the smiley face. What a math funny humor joke. Let's do some examples. I have something complicated to the 0. Don't worry about it, because anything to the 0 is always 1. So 2/3 to the 0, it's 1. Why? Because anything to the 0 is 1. But to understand 3 to the negative 2, this is a little more tricky. I'll try to explain it in 2 different ways. First of all, we can think of reciprocating. 3 to the negative 2 is the same as 1/3 to the positive 2, which is 9. Or if you don't like thinking about things in that order, or sorry, it's not 9. What am I? It's 1 over 9. Here's your answer. Or if you don't like thinking about things in that order, just think, 3 to the positive 2. That's 9, right? But remember, 3 to the negative 2 is a reciprocal, so this needs to be 1 over 9. Why 1 over? Because of the negative exponent. Similarly, let's think about what is going on next. Negative 8 to the 2. Well, that's negative 8 times negative 8. Those negatives are going to cancel. This would be 64. But wait, it's not 64. It's, because of the negative exponent, it is 1 over 64. Tricky. Let's take a look at this one. If 3 to the negative 2 sends the number to the bottom, does it make sense that a negative exponent on the bottom should send the number up to the top? So 1 over 2 to the negative 3 is the same as 2 to the positive 3, like on top of the fraction. So 2 to the third over 1, or just 8. A more confusing way of writing this is 1 over 2 to the negative third is 1 over 8, because I know 2 to the negative third is 1 over 8. And this happens to be 1 times 8 over 1 because dividing is the same as multiplying by the reciprocal, right? That's what fraction division is. And hey, this is 8. So I tried to explain things kind of scattershot approach there, try to give you some different ways of thinking about things, but just know negative exponents mean reciprocate. That's why 3 to the negative 2 is 1 over 9. That's why 1 over 2 to the negative 3 is 8 on top of the fraction. Some more examples. So we can mix in exponent rules with negative exponents. For example, let's take a look here. I have 6 to the negative 4 times 6 to the 4th. Now, let's not get freaked out by the negatives yet. Don't get all crazy on me. Just remember that if you have the same base, if you have a power times a power, what do I do with the exponents? Well, I need to add those exponents. What's negative 4 plus 4? It is 0. And what's anything to the 0 power? Well, it's 1. So I don't even really need to worry about the fact that this is negative, except that when I do the addition, negative 4 plus 4 is 0. So how did I get the 0? I added the exponents because this is product of powers. Next, don't worry about this negative exponent. What's going on here? I have a power to a power. I need to multiply these exponents. So this is 4 to the negative 4. Okay, now I need to worry about the negative exponents. So I think the way I like thinking about it is what's 4 to the positive 4, and then I can just kind of remember to flip it at the end. 4 to the 4, let's see, 4 times 4 is 16, times 4 is 64, times another 4 happens to be 256. It's a big number, but I can do it in my head because I'm a pretty smart guy. But remember, it's not 4 to the positive 4, it's 4 to the negative 4. And what do negative exponents mean? They mean take that smile and turn it upside down. Reciprocate. This is 1 over 256, not just 256. Easy. Likewise here. If 3 to the negative 4 is on the bottom of a fraction, remember that that means actually this is 3 to the positive 4 over 1. I reciprocated because it's a negative exponent. That means reciprocate. What's 3 to the 4? Let's see. 3 times 3 is 9, times 3 is 81, times 3 is, I think, 243. Again, I'm a pretty smart guy, so I can do this in my head. Here we go. All right, finally, this is maybe the trickiest one yet. I have 5 to the negative 1 over 5 to the 2. Let's think about it. Typically, when we have a fraction involving exponents with the same base, we know to subtract. So, negative 1 minus 2, well, that would be 5 to the negative third. But remember, this means 1 over 5 to the third. And what's 5 to the third? Well, it's 125. Here's another way that you can think about it that you might like. 5 to the negative 1 over 5 to the 2. Let's see. I know that 5 to the negative 1 needs to be reciprocated. So wouldn't you say that I could write 1 over 5 to the 1 times 5 to the 2? Look, I reciprocated this. I sent it to the bottom. Now there it is on the bottom, multiplying 5 squared. 5 squared is 25, and times 1 more 5 is 125. So this is still 1 over 125. You can think about it in either way, and that's a cool little proof for why it works out. Let's do the last examples. I know that I need to distribute this cube in, and I do have a negative exponent here. So let's think about this step by step. 2 cubed, x cubed, and y to the negative 5 cubed. Well, 2 cubed is 8. X cubed, it's already as simplified as it will be. Y to the negative 5th to the 3rd. That would be y to the negative 15. Y, power to a power. Exponents multiply. But I know that this y to the 15th actually belongs on the bottom of the fraction. It needs to be reciprocated. So this is really 1 over y to the 15. And if I perform the fraction multiplication, 8x cubed over 1 times 1 over y to the 15, we see that this should be 8x to the 3rd over y to the 15. You can get used to just doing this. If you see a negative exponent, send it to the bottom. Last example. This is the trickiest one. If you've made it this far through the video, you're not really needing to be congratulated. You're doing your job as a student. Way to stick through it. Okay, I have some complicated things going on here. First of all, I have a negative exponent. Remember, this negative exponent, it went to the bottom of the fraction. That means everything that's being taken to this negative 2 needs to go to the bottom. So let's do that. I have y to the 5th. This thing is gone. It's no longer on the top. Now it's on the bottom. So here it is, living on the bottom. This is complicated. Next, let's see. I have y to the 5th on top. Maybe I'll distribute this through. This is 4x squared times negative 4x squared y squared. Just multiplying things together. On the bottom, I have negative 4 times negative 4. This is negative 16. I have x squared times x squared. That's 4 x's. And I have that y squared not doing anything. But oh, wait. Look, I have y to the 5th on top. I have y squared on the bottom. And y to the 5th over y squared. 5 y's on top, 2 y's on the bottom. Things will cancel, leaving me with just 3 y's on top. On the bottom, negative 16, x to the 4th. That was a complicated one, but think about what we did. First, we sent this negative exponent packing down to the bottom because I know that negative exponents need to be reciprocated. Now, I distributed through. I combined some like terms, I combined some more like terms, and came up with that as my final answer. This was a long video. It was a complicated video. Way to make it through. Here's your summary. Something to the 0 power is always 1. Stick figure to the 0, 1. Negative exponents need to be reciprocated. So if you have something like 1 over x to the negative 1, it needs to be reciprocated. Now it's just regular x to the 1 on top of the fraction. X to the negative 1 needs to be reciprocated. Now it's 1 over x to the 1. It got sent to the bottom. Hope you enjoyed the video. Hope you liked the flipping. See ya.